take a look at the homework now. As we talked yesterday about a new type of graph, and this type of graph we kind of, instead of showing individual data points or individual results, we kind of group things in together and we show frequency within groups. What type of graph did we talk about yesterday? You had to draw one of these yourself, in fact, for homework, where we group data into classes and then show frequency within these classes. Jalen? A histogram. And that is not what we see at the top of page 33, or page 330 rather. How do I know that that is not a histogram? How do I know that's not a histogram? Two things. Kirsten?
Because the bars are separated.
The bars aren't touching. A histogram is always going to have bars touching each other, but also...
Because of this.
There aren't actually any groups here, are there, class? It just says Monday, Tuesday, Wednesday, Thursday, Friday. They're all separate days. Now, I didn't say weekdays and weekends or things like that, right? They didn't group anything together. So we know it's not a histogram from that regard as well. One other thing. On the graph, do you look at the bar and do you see how the bar itself is labeled Monday? In a histogram, we don't actually label bars. We label the edges of bars, right? So we would label 0, 10, 20. We label the edges of bars to show classifications falling inside. That's one of the other big differences. Bar graph actually labels the bar. You actually label the division points between bars on a histogram. So that's one of the other differences we see. Let's take a look at the answers, though. Number 13 at the top of page 330. What is the value of each minor grid line, Joel? 1. On what day did the greatest number of students bring their lunch to school? Michael? Monday. A little bit less throughout the week, and then Friday. I don't know, maybe they had like Pizza Day Friday or something, and so not as many kids brought their lunch. I don't know. Number 15. On what day did 15 students bring their lunch to school? Ben?
Thursday.
Thursday. Number 16. How many students brought lunch to school on Tuesday? Corey? 18. And then for numbers 25 through 27, just some quick algebra, order of operations, signed number review. Which got on 25, Luciana? 11. Number 26, Elaine?
4? No, 8.
Oh, Jalen?
Negative 28.
Oh, the pain. Number 26?
I got positive 8.
Joel?
Negative 8.
Negative 8. Oh, we'll take a look at that in a second. Back to Elaine for redemption. Number 27.
4.
4 is correct. Okay, let's look at 26 real quick. So it says 6, positive 10, negative 24. In class, I don't see a sign in front of the 6. You know what that means it is?
Positive.
It's positive. And remember what I told you, the best approach to use here is group together positives and negatives if there's a lot of them. If I group these two positives together, what does that give me, class?
16.
Positive 16. Because they're both positive. Signs are the same, add and keep the sign. Now we put these two together. The signs are different. Now we subtract and keep the sign of the greater absolute value. So that's what we should have done there. Or if you just went in order, what's 6 plus 10?
16.
16. Can you subtract 24 from 16? No, then you can add the inverse and you still get negative 8. To me, that's the longer way to think through it. I just think, hey, 16, put the 16 with the negative 24, there's your negative 8, but it works. Does anyone have questions on any of the other problems in the review section that we went over? All right. Let's skip over the histogram for a moment on page 330. We're going to come back to it. Let's instead look at the histogram that's already drawn for you at the top of page 331. And we got some football players. And we got some big, tall, large football players, apparently. We got some kind of short, very skinny, get broken in half kind of football players. We got some short, squatty, fat football players. And then we got the lean, mean, wide receiver looking machine. So we got a little graphic there. And they've broken the football players' weights into groups. So the smallest group weight of football players, the little guy, who's going to get broken in half if you're not careful. That group of football players weighs how much, Kirsten?
150 to 175.
150 to 175 pounds. Now, when I was in high school, I would have actually been below that. I didn't play football, okay? And Michael's over there like,
For shame.
this is why we have Pee Wee League. I'm just picking up. Anyway, the next weight class, the next weight grouping is how much there, Jalen?
225 to 250.
Oh, no. I didn't ask what the biggest was. I said, looking at the graph, The smallest weight grouping is 150 to 175 pounds. If you weigh anywhere in there, you're in that group. The next weight group listed is
175 to 200.
175 to 200. That's where I would be now. I eat too much and run too little. The next group that we have, Elaine, would be
200 to 225.
And then the biggest group, the most common weight of people on this football team, falls in that next category here. Luciana?
225 to 250.
There we go. Now, according to this histogram, on the football team, the heaviest person must weigh less than what, Corey?
250.
The heaviest person on the football team has to weigh less than what? 350. Because the chart only goes up to 350. So apparently the heaviest guy, the big offensive lineman who just crushes people, that Michael, like, I'll be the running back behind that guy. He clear the path. I'll skitter through there. But 350 pounds is apparently the top weight on that football team. All right, so question number 2. What's the value of the minor grid lines class? 1. And we actually already answered number 3. Which weight class do most of the football players belong in, Ben?
I don't know.
Number 3. What was your answer?
Oh,
Come on, man.
225 through 249.
Well, yeah, 225 to, we'll say 225 to 250, but you're right in this sense. If you're 250, you are going in that next weight class, right? But what if you're 249 pounds, 15 ounces? Well, normally, if you step on a digital scale, it would say like 249.9 pounds. But you're still in that class, right? So until you actually get to 250, so we'll say 225 to 250, but you're right in the sense that if you were actually exactly 250, you'd bump into the next class. Which weight class contains exactly 4 football players on the team? Michael?
Class 4. I'm at 275 to 300.
The 275 to 300 class. Good. Number 5, how many more players weigh between 300 and 325 than between 325 and 350? Joel?
4.
I'm sorry?
4.
4. There are 4 more, right? Because in the 300 to 325, there's 9 of them, and there's 5 of them in the 325 to 350 class. How many players weigh less than 225 pounds, Kirsten?
23.
23 people are under 225 pounds. How many, this isn't one of their questions, class, how many people are in that 225 to 250 range? Anybody? 17. So we already had 23 people below 225. Add 17 more, we're up at 40 players. How many are in the next weight class? 8, so we're at 48. Then in the next class?
4.
So we're at 52. In the next class?
9.
9. So that takes us up to 57? Wait, this is 40, 48, 52, 61. And then add 5 more that way. 66 players? Anyone find the total? My math is now screwy and my brain suddenly stopped working. I think it's 66 players. If they'd asked a question, and the reason I was going to go into that, if they asked what percent of players weigh less than 225? Well, we said there's 23 players like that, right? That was one of your questions. How many weigh less than 225? Well, there's 23 of them. If they said what percent weigh less than 225, we'd have to divide the 23 by the total number of athletes. So if that number was 66, we divide by that and make that fraction, do the division, we could get our answer there. Questions on how to read a histogram if it's already been built for you. All right, before we look at the histogram you made, let's go over 15 through 17 very quickly. Number 15, what you got there, Joel?
Negative 13.
-13. Number 16, Michael?
Negative 4.
-4. And number 17, Ben?
Negative 51.
Not quite sure what you did there, Kirsten.
Negative 36.
Should be negative 36. Ben, real quick, order of operations. What's the first thing we have to do on the last problem?
Multiply.
No. Combine. Combine inside the parentheses. Remember, parentheses come before. This does say to multiply, but before we can multiply, we have to combine like terms together. And so what is negative 6 plus positive 3?
3.
Keep the sign of the greater.
Negative.
Right, because if I took $6 from you, like, Ben, I was a real jerk to take $6. Here's $3 back. I'm still a jerk. I'm less of a jerk, but I'm still a jerk to the tune of $3 that I stole from you, right? So it's not positive 3, it's negative 3. You're still out $3 here. And then we multiply negative 3 by the 12 because the parentheses have been solved. That's where we get the negative 36. All right, questions on that part of the homework before we look at the histogram you made? Any questions at all? All right, let's now look at the histogram. Read what it tells us there in number 1 and kind of read through the chart real quick for us as well, Kirsten.
While working his shift at a restaurant, Jerry kept track of how many customers he served each hour. 4 p.m. to 5 p.m., there were 24 customers. 5 p.m. to 6 p.m., there were 34 customers. 6 p.m. to 7 p.m., there was 32 customers. 7 p.m. to 8 p.m., there was 28 customers. 8 p.m. to 9 p.m., there was 23 customers. And 9 p.m. to 10 p.m., there were 19 customers.
All right, now I will say this. I don't think he needed to keep track, like keeping a pencil tally going, right? Because the register keeps track of how many transactions you've made. But anyway, he's keeping track of all this for his boss. Maybe the boss is like, hey, you're smart. Do this for me. I'll pay you a little extra. Give you a bonus. I like a bonus. So first thing you needed to do, you needed to set up across the bottom, you needed to set up your labels here. But remember, on a histogram, when we label, we don't label the bar, we label the divisions between the bars. So we're actually going to label the beginning of the whole graph. Should start at what time, class? 4 p.m. Then the next division has to be 5 p.m. Then
6,
and then
7,
and then
8,
and then
9,
9. We do still have to keep going. And then 10. Now, if they close at 10, do I need to have any extension off here? No. So then we could go through with the eraser and we could just erase a little bit off. Now, if you were using graph paper, then you could just know, okay, if I want each bar to be 1 box wide or each column to be 1 box wide, I just count 1, 2, 3, 4, 5, 6 different boxes. Or you could do 2 boxes wide and just do, 12 boxes. But if you're doing it on normal notebook paper, like most of you did, that's going to be a little bit challenging. Then we need to go up the side here for our scale. And let's see. The biggest number of customers he had at any one point, class? 34. Should that be my top number? No, because it can't hit the top. So I need to at least have what number at the top? 35. If I do 35, I would have to break down how many for each minor grid line. Or for each major grid line, rather. Every 5, probably, right? If it's 35 at the top, we'd have to go 5, 10, 15, 20, 25, 30, 35. That'd be 7 major grid lines. What if instead of going just 1 higher than 34, what if I went to a nice, even more round number like 40? Well, now if I go all the way up to 40 at the top, now I might only need major grid lines every 10, right? 10, 20, 30, 40. Lazier. You with me? Yeah. So I'm going to do that. I'm going to set my top line at 40. And so then I just need to figure out, okay, if I'm going to go 10, 20, 30, 40, let's go a little bit shorter than that. So we'll go 10 customers here. It would help if I had lines on the paper. 20 customers here. I think I shortchanged myself. 30 customers here. Yeah, I didn't do that too even. So we'll go 40 customers here and make good use of the eraser. Again, if you had lines on the paper, you could plan this out ahead of time. I happen to not have lines on the board. But again, it's not wrong if you did other major grid lines, right? It's just not as lazy. I'm lazy. Now, if I go every 10, that's a really big gap, right? So I should probably put some minor grid lines on here as well. What would be a natural minor grid line to use if I'm going 10 for the majors? 5. Now, could I do every individual one? Oh, that's murder. 1, 2, 3, 4. No, I don't want to do that. Even every 2. Murder. No, let's just do every 5. So we'll just real light. In fact, I'll use a different color. I'll go purple here. And we'll do there's a 5 minor grid line. Again, it would really help if we had lines on the paper, but we don't have lines on the board. So, 5 and 5. So again, as you're doing it, you want to make sure you do it well and at the same time be a little bit lazy, okay? So, neat, because we're, doing a good job, whatsoever our hand finds to do, but we can also, find areas where we can take shortcuts and still have it turn out good. I am still missing a title at the top, though. And Kirsten, did you remember to put a title at the top of yours? What was your title?
Customers served, and then put in parentheses each hour.
Customers served each hour. All right, I like that title. Or you could say customers, Jerry served, Jerry's customers. How many mentioned Jerry in the title? All right, probably good because, it helps us know. Do we need an axis title over here?
Yeah.
Not if you specifically say the whole graph is about customers, but if you said, so if you didn't mention customers, then we need to make sure we know this is the number of customers. And then down here, I think it's pretty obvious, 4, if you wrote PM, we know it's talking about time. Now, if you just wrote 4, 5, 6, 7, 8, 9, 10, you would have to put time of evening or something like this in the bottom so we know that we're referring to time. All right, so let's look at the first number. The 4 to 5 bar needs to go how high again here, Elaine?
It needs to go to the 24.
Now, I don't have a minor grid line for that, do I, class? Is that a problem? Not really, just go a little shorter than 25, which is my purple grid line. So if I go just a little shorter, and then we go straight down, and then remember, we're going to want to shade in a little bit. I think we can all tell that means 24. If we're not positive, we might think it could mean 23 or 24. Does that make sense? But a graph is an approximation anyway. I think it's close enough to 24. We can tell what that means. Okay? Then the next number that we need, Joel.
34.
Now here's the key. I went about a pinky's width on the board below the purple line for 24. I better go that same width below the 35 line for this next one. So I'm going to take my bar up to here. Again, it's about a pinky's width. And we're going to go up. And we'll erase a little bit off the edge there, just nice and neat as we can make it. And we'll shade in. And then Ben, what about from 6 to 7 p.m.?
32.
32. Now at this point, it's just going to be just a little bit above. Now 32 though, not a pinky's width above the 30, but a little bit more than that, right? You see how this is less than halfway from 30 to 35, just a little bit, but it's clearly not 31 either. And so again, I think this can approximate our 32. All right. Then the next hour, Michael, he served 28. So, however, this a little bit higher, maybe it's more like a thumb width above the 30. Well, 28 is going to be that same about thumb width below the 30. And we'll go down here. I think I might have shortchanged that just a little bit here, but we try to be nice and neat. Again, if you use graph paper, works great. The next hour, he served Jalen. We didn't serve Jalen, but Jalen, how many did he serve? 23. 23, that's going to be about that thumb width below the 25. Now, so not this little, that's 24. 23 is going to be a little bit lower than that still. And we shade that in. And then the last bar needs to be what, Luciana? 19. So just that little pinky's width below the 20 here. And we'll shade that in. And there we go. And that's all it takes to make the histogram. Again, the key, be smart with your grid lines. Don't, well, 0 technically there. But be smart with your grid lines. Be smart with your minor grid lines. We don't want to have to draw too much. Make sure we label the divisions between classes, not the actual bars themselves. Make sure we remember a title. It'd be even cooler if we'd used colored chalk, and I had the green chalk here all along and didn't even think to use it. Questions on the histogram? All right, so which type of graph is used to show the relationship of parts to the whole, class? Circle graph. Which one is used to compare related but independent data?
Bar graph.
Which one is used to compare related but independent data while also showing groups within that data?
Stacked bar graph.
Stacked bar graph. Which one is used to group data into classes and then compare those classes or show frequency within groups? Histogram. Let's take a look at another one now. Turn over to page 332 and let's talk about the line graph. And you see there on page 332 something that I'd emphasized once before about the line graph. You see it in bold is to show how data has changed over time. Changes over time. You can write that in a little bit bigger letters across the top of the page. Changes over time. We were tracking Ben's growth chart. and we show Ben's growth. And when he was, born, he was, inches tall at that point. That's how we measure it. And then, when he's 1 year old, now he's this tall, and 2 years old, now he's this tall, and 3 years old, now he's that tall. We could track a bar graph to show Ben's growth until now he's 6'1" or 6'2". Which one did you say, Doug? 6'1". Till now he's 6'1", and it just could keep going. We don't know. And so we could track that change over time, right? Now, did Ben suddenly one day just grow 2 inches over what he'd been the previous day? No, that's not how it happened. But over a period of hours, of course, he would gradually grow. Over a period of days, he would grow. And next thing you know, it's like, wow, last time we measured you, you're now 2 inches taller. But was it a sudden change? No, that would be very painful and probably be anatomically impossible. But changes over time. We said temperatures change over time. But look at the graph that we see on page 332. Toy shop sales. Do toy shop sales have to be gradual, or is it actually possible that one day a bunch more customers than usual could walk in all of a sudden and just buy stuff? Does it have to be gradual? No. Gas prices. Do they have to change gradually over time, Michael?
No.
They could just suddenly change because OPEC decided to, and we're now dependent on foreign oil. So we got to pay what OPEC says because we can't drill our own. Exporter. Anyway, not trying to be political or anything here. Anyway, so things like that are what are called broken line graphs. Broken line graphs. If you'll write that off to the side of page 332, we talked about this once before. Sudden or sporadic changes. Broken line graphs. Sudden or sporadic changes. Discontinuous changes. Sudden changes, use smaller words for 7th graders, okay, are broken line graphs. But if you flip over a couple pages to page 334, flip one page technically over to page 334, you'll see they talk about the broken line graphs versus a curved line graph, which is more gradual, continuous curve, and a straight line graph, where everything just goes in a straight line. There's different types of line graphs. Primarily in this class, we're going to be using the broken line graphs, though. Okay, so it talks about what the other ones are in that little fast fact. You're not actually going to have to graph straight line graphs or curved line graphs in this class. We're going to be doing everything with broken line graphs. Notice, if you would, at the top of the graph, you still got to have Class A chart title. Yes, they have that there. And the title of our graph at the bottom of page 332, go back there now. Title at the top, page 332's graph is what, Corey?
It was Toy Store Sales 2017.
There we go. And so we know exactly what year we're talking about. We know whose store we're talking about. And along the bottom is where they put the labels. That's good to know. They're going to put labels across the bottom like a vertical bar graph. And the labels are all the different months of the year, because we're tracking change over time. Very often, class, your labels across the bottom will either be years or months, because you're tracking changes. Here, Ben's age at different points. Age 1, age 2, age 3. That's the time change going across the bottom. Up the side will be the scale. Since we're talking about sales, we're going to have money on the side. For Ben, we would have had heights in inches, perhaps, going up the side. And Taylor's Toy Shop. We see that the sales go up and then they dip, and then they go up and then they dip, and then they go up and then they dip, and then they go up. The highest month of sales, question letter A, and you see the answer there, but you don't even need to look at it. You can see the graph. What's the highest peak of sales, class?
December.
December. Thoughts on why that might be? Christmas, yes. What's the second highest month?
July.
Huh. July. That's interesting. Wonder why so many toy sales in July. What do you think? Idea, Joel?
July the 4th?
Possibly July 4th sales. I don't usually associate that with toys, but there could be. Some people might give presents for that.
The summer.
What about the summer?
It's
Where are the children in the
get
summertime?
out of school.
They're out of school, they're at home, they're driving their parents nuts. And so the parents are like, if I buy the kid more toys, maybe I'll have some peace. Now, you all know this. Does that work? No! The toys just make a bigger mess and drive the parents more nuts. But parents will try it. Or might be pool toys that are being sold in the month of July. It's actually warm enough in July just about everywhere in the world that in the U.S. that you can go jump in the pool and not freeze to death. But how many have a pool at your house? Do you have a pool at your house? Anyone? A couple of you ish. Okay. Yeah. What I have found is that we don't have a pool, but I have found though in visiting other pools. By the way, we'll throw a shout out here. I'm not even sponsored by them. Unless they want to sponsor me, Swimply. Anyone ever heard of that app, Swimply? It's like an Airbnb for pools. So you don't have a pool, you can go rent an hour or two at another person's pool. And so different pool owners will advertise their pools on Swimply, pay 20, 30, 40, some of the really nice pools might be more, we don't go to those because we're cheap, but 20, 30 bucks an hour and you can use somebody else's pool. You don't have to maintain it, you ain't got to clean it, you just show up, enjoy the pool, and leave. They get money, you got pool, but I found this in June, it's not, especially early June, freeze getting in that pool water. July though, it's plenty warm. By August, it's hot. I don't want to get in the pools in August. So we found that out one summer because we did a lot of Swimply. We're like, we're not going anywhere on vacation this year. We're just staycation, but we're going to rent pools and just have a good time swimming this summer. And I found out June is cold, July is perfect, and August is warm and nasty. But anyway, there we go. So Swimply app, you heard it here first, and Swimply can endorse me and send me a check. All right, anyway. I've sent plenty to them. Anyway, let's see, letter B. Between what 2 months was there the greatest drop in sales? Where do we see the biggest plunge in toy sales at the toy shop? Kirsten? July to August. July, we're on vacation, let's buy toys. And August, it's back to... And nobody has money for toys because they're buying school supplies, school uniforms, things like that. What was the decrease? Well, how high were sales in July, class?
30.
Looks like about 32,000, right? Right around 30. Well, it's actually just below the 32,500 mark, but right around the 32,000 mark, right? What about in August? Touch below 20,000, right?
19,000.
So yeah, between 32,000 and 19,000, about whatever that drop is, about 12, 13,000-ish. It says 12,500. How many times did sales increase? Ooh, that's an interesting question. Let's look at the first 2 months. January to February, class, was there an increase?
Yeah.
Yes, there's one. Okay, February to March?
Yeah.
Yes. March to April?
No.
Don't count it. Okay, April to May?
Yeah.
Yep, May to June?
Yeah.
June to July?
Yeah.
July to August?
No.
No, okay, don't count that. August to September?
No.
No. September to October?
Yeah.
Yes. October to November?
Yeah.
November to December?
Yeah.
So how many months did sales go up?
8.
8 different times. Now, how many times did we see a trend of sales going up? Now, how many months, but how many times do we see a trend of sales increasing, class?
8.
3. Do we see the trends from January up to March, and then April up to July, and then kind of from September up to December? You see that there are 3 times that the sales progressed upward. But there were 8 separate months in which sales increased. Do we see the difference in the way the question's asked? Okay. Here's a question. How many months were sales over $20,000? That's not one of their questions. That's one of my questions. How many months were sales over $20,000? Well, what I would do is I'd take your pencil and mark right over that 20,000 line. Just put a line right over their 20,000 line. Just count how many times is there a dot above your mark? How many times is there a dot above your mark? Michael said 6. He's correct. Michael, what months do you have a dot above 20,000?
March, April, May.
Not April. April's below 20.
May,
May,
June,
July,
November, and December.
November, December. There we go. So if you're asked how many months was sales above a certain mark, mark over that line, find the number of times the dot's above it. What were the lowest sales? What were the lowest sales of the year? Ben?
January.
Yeah, September we see a pretty big drop there as school's really getting going. There's also a pretty good drop in April, but the lowest point is January. Why? Thoughts?
Christmas is over.
Christmas over, ain't nobody got no money. Okay, they bought all the toys in December. We ain't buying no more toys this month, and then they lose their resolve around Valentine's, and then they lose their resolve further as they get towards spring break. And anyway, yes, sir.
But what if someone had a birthday?
They don't get any toys in. Just kidding. I mean, there were still some sales. There weren't much sales. What's the value of the first minor grid line? Or what are the value in general of the minor grid lines, Jalen? 2,500, because the major grid lines are 5,000, halfway between be 2,500. How many sales in February? What were the sales in February? And everybody, the only toys they're buying there are like stuffed animals, and then they're buying chocolate. That's not toys. And anyway, Elaine?
15,000.
Yeah, it just looks a touch below 15,000 in February. So I don't know, maybe guessing 14,000 or anyway, close to 15,000. And what about in September? What were the sales in September? Corey?
Like maybe 17.
Yeah, I'm guessing about 17. It's just below the 17.5 line, so maybe around 17,000. The book says 17.5. All right, do we see how to read a line graph? Any questions on how to read a line graph? Look across the page. Sometimes you can make comparisons on a line graph. You're still tracking change over time, but you can track two different things at the same time. Look at, if you would, the graph on page 333. And we're going to track two different types of gas. Now, they broke one of my cardinal rules here. What did their line graph do that it should not have done, class?
Touch the top.
It hit the top. Okay, if you did that on a line graph, you would lose points. Points off of Becca for hitting the top of your graph. Don't do that. But anyway, there's two different types of gas, though, that they're tracking here. What are those, Luciana?
Regular gasoline and diesel.
Regular and diesel. So regular, what most folks use, and diesel, what the big trucks use. And we can watch. And notice at the beginning of the year, do you see they're really just tracking together very nicely? Or excuse me, in the years, they're tracking very nicely. 2000, 2001, 2002, 2003, 2004. And then 2005, they begin to separate just a little bit, and the diesel begins to rise above. And here's the diesel just stays just above all the regular gas kind of on throughout. We see all that? Mm-hmm. Now, this graph only goes up to 2015. There's a year in which I think you would see diesel really way higher than regular gasoline. And it wasn't too long ago. Guesses?
2020.
2020, because where was everybody in 2020? Stuck at home, except the truckers who were considered essential workers who had to ship stuff, right, to keep the stores going. And so the truckers were out on the roads while we were staying home. That's one of the reasons, by the way, why prices dropped so low in 2020, because nobody was buying gas. Nobody needed gas. Well, I say nobody. I mean, a lot of you didn't. Anyway, which of the years on the graph has the lowest price for fuel? What was the lowest fuel price on the graph, class?
2002.
2002. Do we all see that that's the lowest one? Where's the highest price on this graph for fuel?
2012.
Yeah, 2012. Everything hit the high point there. In 2009, what did it cost for a gallon of regular gasoline in 2009? What was gas costing? It says $1.80. Yeah, it's between, it's just under the $2 mark. Well, diesel's right under $2. By the way, how much are the minor grid lines here?
50 cents.
Well, the major grid lines are 50 cents. So the minor grid lines would be 25 cents, right? So $1.75, the 2009 blue dot is above the $1.75 by a little bit. They say $1.80, $1.85. Again, there's some latitude here, right? If I were asking this as a test question, you said $1.80, I give it to you. You said $1.85, I give it to you. Said $1.90, I might take a point off because it's pretty, like if you said $1.90 about the red dot, I might give that to you. But anyway, how many years did we see an increase in fuel price? Now here we go again. Let's see. 2001 class?
No.
No? 01 to 02?
No.
02 to 03?
Yes.
Yes. 3 to 4?
Yes.
4 to 5?
Yes.
5 to 6?
Yes.
6 to 7?
Yes.
7 to 8?
Yes.
8 to 9?
No.
No. Prices went down. 9 to 10?
Yes.
Yeah, 10 to 11?
Yes.
11 to 12?
Yes.
That's where it hit the high point. 12 to 13?
No.
13 to 14?
No.
14 to 15?
No.
No, price coming back down there. And in 2016, which would you expect to be more expensive, regular or diesel, class?
Diesel.
Because diesel stayed higher for the past decade at that point, right? So we'd expect diesel to still be a little bit more expensive. All right, do we see how to read even if there's two different lines? All right, so let's flip over to page 334. Page 334. And they call it a category label. We could also call it an axis title still. What is the axis title for the vertical axis? Oh boy, okay class, what does vertical mean?
Up and down.
Up and down. Okay, so the up and down axis, what is that axis title? Jalen? Price in dollars per gallon. There we go. And number 2, what's the category label, or I call it the axis title, for the horizontal axis? Joel? That's the vertical one that we just wrote for number 1. We're on number 2. What's the category label for the horizontal axis? Years. What's the chart title, Michael?
Milk prices.
So clearly, class, what are we looking at?
Milk prices.
Price of milk over the years, right? Dollars per gallon. All right, so what are the lowest 2 years as far as the price of milk? Which 2 years have the lowest price for a gallon of milk? Luciana?
2009 and 2006.
Good. Right at the beginning of the graph, 06 to 09, and 09 rather, had the lowest prices of milk. What was the highest price of milk? What year was milk at its highest price per gallon? Elaine?
2008.
08. Good. About how much did a gallon of milk cost in 2012? Ben? Well, how much are the minor grid lines here, anybody?
20 cents.
About 20 cents, right? There's 4 of the grid lines, 5 spaces from $3 to $4. So we're talking about 20 cents a grid line. So 2012, what would that be?
340.
Well, it's just above the 340. If they're 20 cents each, you had 320, 340. It's just above 340, so maybe
345.
345, 350. I would take any of those. 345, 350, even 355. 350 is probably what it is, but I would give you a little leniency there because again, the graph is an approximation here. Does the graph show that milk prices continue to rise every year? Kirsten?
No.
No, it's up and down, right? It fluctuates. So we don't see a constant trend upward. What years had the greatest change in milk price? Where do we see the biggest change, either up or down, in milk prices? Corey?
2008 to 2009.
Yeah, we saw a big drop from 08 to 09 in the price per gallon of milk. How many of the years, at your seats, look this up and then write it down. How many of the years did the price of milk go up? How many years did the price of milk go up? Find it, write your answer. Joel's got it. Several people got it now. Joel?
6.
The book says 5. Let's look.
Yeah.
6 to 7, 7 to 8, not 8 to 9, 9 to 10, 10 to 11, not 11 to 12 or 12 to 13. 13 to 14 went up, and then, yeah, so it is 5. And then the 14 to 15 dropped. How many had 5 years? All right. And again, we're looking from year to year. So we're not looking at the dots, but actually about the lines that are going upward. Based on this information, do you think in the future we're going to see the price drop below $2 a gallon? What do you think? I'm seeing some people shaking heads. No. Why? Okay, never been below $2 a gallon, at least not anywhere on this graph, right? Would we expect it to ever drop below $3 a gallon?
Yeah, maybe.
I think it could, based on this graph. It's been really close to the $3 a gallon. It's never actually been below it. Would we expect it to go over $4 a gallon?
Possibly.
Maybe.
It wouldn't shock me. It doesn't take that much to make prices go up. So I think realistically, you could see it go over 4. I actually don't know what it is right now. Shall we Google it?
I saw that.
I remember egg prices went up really high.
Yeah, egg price has been crazy lately. Let's find out. Let's find out about milk price real quick. We're doing this live. All right, so hush. Price of a gallon of great value milk. We'll go cheap end here, okay? $3.45 right now at Walmart for a gallon of great value milk. Any of you milk snobs, you do not buy the great value? Y'all buy the Borden milk or the, what are the other brands of milk out there?
Great value slaps.
I don't know. Prairie Farms or something. I don't know.
What is that?
It's like the pet.
I don't know. Anyway. All right. Let's continue on. Flip over. Flip across the page. Let's look at the precipitation. Precipitation. What does precipitation mean, class? Rain, snow, sleet, anything that falls from the sky, right? Normally rain, but even if it ain't rain, when it hits the ground, it turns into water eventually anyway. All right, so looking at this, what 2 cities are we comparing their precipitation, class?
Danbury, Connecticut, St. Paul, Minnesota. 26.
There we go. From the little legend there. Legend. We see that the blue line is the Danbury, Connecticut, and the red line is St. Paul, Minnesota. Which city gets more rain, class, or more precipitation?
Danbury.
Connecticut, definitely getting more than St. Paul, Minnesota. All right, so number 13. For the following months, how much precipitation did St. Paul receive? Now hold on, let's look at this. This is in inches for these various months, right? So the minor grid lines then are like 0.2. Do you see that? There's 5 grid lines for every one, or 4 grid lines plus the 5th is the major. So 0.2. So January, how much precipitation in January, class?
0.6.
0.6, because it's up to the 3rd grid line. What about in April?
2.8.
Careful, it's just under 2.
1.8.
1.8. And then in June?
4.4.
3.8. Yeah, June. July is the 4.4. Which month did Danbury have the most rain or most precipitation? When did Danbury have the most precipitation, anybody? July was their highest month. July was their highest month. By the way, what wouldn't hurt is if you took your pencil, started at the bottom, just went straight up to help yourself see where these lines are. Because it is kind of hard, isn't it? Like all the months kind of blend together. You don't have those vertical grid lines. You can make some vertical grid lines if you wanted to. What does the vertical scale show? Elaine?
The inches in rain.
The rain in inches. Good. What about the horizontal labels? What do those show, class? Months. All right. Which 2 months had the least precipitation for Danbury? Which 2 months had the least precipitation for Danbury? Michael?
January and February.
Yeah, January and February were the lowest. What about in St. Paul? When did they get the least precipitation, Joel? January, February. Yeah, the winter time doesn't get a whole lot of other than snow, I guess. Kind of surprised they wouldn't have more snow. And hold on, stay with me. In March, what's the difference in precipitation? Ooh. What we want to do here is let's get what Danbury's precipitation was in March. Stay with me. How much precipitation in March for Danbury, class? 4.4. What about for St. Paul?
1.6.
1.6. So if we subtract, what's the difference in precipitation?
2.9.
2.8. 2.8 inches. Now, if you read the blue dot as being just above the grid line, I could see where you went 2.9, so I'd probably give you that if this were a quiz or test. What's the difference in August? What's the difference in August? It's just 2 grid lines, isn't it? So we don't need to define what they are and subtract, just 0.4. 0.4, 0.2, 0.4 is our difference. Questions on line graphs? Feel like we can read them okay? All right, we'll worry about actually making them in our next lesson. But for homework this evening, page 337 in the homework section. Page 337 in the homework section. Do 1 through 5, 7 through 11. 1 through 5, 7 through 11. Page 337, homework 1 through 5 and 7 through 11. Have a wonderful rest of your day. You are dismissed.